Welcome to Study Loop.
Let's evaluate the given integral. Here, before we do partial fractions, we should see if we can factor this quadratic. So we look at the discriminant over here. This is a negative number. So this means that we have an irreducible quadratic, and it's repeated because of the 2. So we'll use what the author calls case 4 to write our partial fraction decomposition, and then multiply both sides by this term on the left. Alright, so that's the right-hand side after multiplying. Go ahead and expand that as much as we can. And after simplifying, we should get this. And there's our constant term, 2b plus d. Though, comparing coefficients, there should be an a here. We get a equals 1. Then here, this must equal 2. So that gives us b equals 0. This equals 3. So that gives us c equals 1. And this over here is minus 2. So this gives us d equals minus 2. So let's go ahead and plug in our values for a, b, c, and d into the partial fraction, and then we'll integrate this over here. So plugging in our constants, there's our integrals. Let's complete the square. So we can write it as this. And let's label these integrals a and b. So for a, let's do a u sub here for a. Let's go ahead and take u to be x plus 1. du equals dx. So up top we have x. Using this, that's just u minus 1. And then we have u squared plus 1. So this is just u squared plus 1, 1 u squared plus 1. Here, you go ahead and do another u sub. So integrating this, we should get 1/2 natural log u squared plus 1 minus, and over here, you can do a trig sub. And we get tan inverse u. And then go back in terms of x over here. So you could go ahead and simplify that. And then u is just x plus 1. So that takes care of this first integral here. Now we'll have to deal with this one. So let's go to the next page to start that. So we had x minus 2 x plus 1 squared plus 1, and that's also squared. Uses the same u sub as before. Then here we have u minus 3. All right, so here, subtract 3 on both sides. So then we could replace x minus 2 up here with u minus 3. So here's what we have for part B. Then let's go ahead and split this into 2. Now for this first integral here in part B, let's go ahead and do a substitution. So this becomes here we'll have 1/2 integral 1 over w squared. And then for this integral over here, trig sub. So then du is secant squared. And u squared plus 1 will be secant squared by the Pythagorean identity. So we have secant squared theta, secant 4 theta. So we could go ahead and write this as secant squared on the bottom, and then use the fact that 1 over secant equals cosine. So let me go to the next page here. And also note here for this first integral, this is just negative 1 over w. So going on to the next page, we have 1/2, and then negative 1 over w, which is u squared plus 1. That's the first integral that we had in red. And then we have minus 3 cosine squared. Now here, let's use the half angle for cosine. Okay, a few more steps here. This we can use the double angle formula to write as sine cosine times 2. Cancel those 2's. And now we can go ahead and get this back in terms of u. So first, recall our trig sub, u equals tan theta. So that means theta is tan inverse of u. So we can start writing that here. And then to find sine and cosine, we'll draw that triangle. So tan is u over 1. So there's my u, there's my 1. Use Pythagorean theorem to find the hypotenuse. And then multiplying sine and cosine, we get 3 over 2. And then we have u over u squared plus 1. So now the last step here is to just go back to the u substitution and replace u with x plus 1. So finally, for part B, we have that's part B. Then the final step here is to just say the final answer, which is A plus B. And then from our previous work, this is part A. So that's A there. And then for part B, so we have negative 1/2. Just rewrote that denominator. And then finally, let's add that constant c. And this can be simplified a little bit. You could go ahead and combine these terms. And we can also combine these terms over here. So I'll write that last step. And this is our final answer. So here, yeah, let me 2x plus 2 negative 5/2. And then we can write the rest. And that's our final answer.